Hello, and welcome to the University of Plymouth Cyber Ship presentation for DEF CON. My name is Kimberly, and today with my colleague, Professor Kevin Jones, we're going to give a brief talk and demonstration on the maritime cybersecurity work we are currently doing. We'll start off with an introduction to the subject and then move on to two short demonstrations. And with that, let me first pass this to Kevin to do the introduction to the subject.
So my job here is basically to give you the idea of why we at Plymouth think maritime cyber threats is a big deal. It might be self-evident, but when we started talking about it a few years ago, that certainly wasn't true. A lot of the sector would say, why bother? Why are we interested in? Doesn't affect us. Now, the shipping sector has been interested in threats for a long time, but for most of history, they've involved people coming alongside with a cutlass in their teeth or something equivalent and actually sort of performing piracy or whatever acts it is they want to do in the physical sense. That's really changed. While there is still physical piracy and it's still a real problem in the sector, even the physical events now rely on cyber to make them safer. And what we've certainly seen in recent times, both within the maritime sector and in related sectors, cyber is becoming almost the weapon of choice for a number of criminal, terrorist, and even nation-state activities. We've seen in the US in recent times, oil pipeline being closed down by ransomware. We're talking about millions of dollars and potentially billions in collateral damage. We've also seen even more seriously people using spoofed or fraudulent identification system tracking to almost cause war-like incidents. There was a recent case where a Navy warship and also a warship from the Netherlands was accused of being where it shouldn't be based on evidence presented from AIS in ways that were clearly false. Although actually I can confirm the Navy said the Royal Navy ship was where it said it was, and for good reason. So this is sort of something that's now becoming very real. How real? Well, within recent times, we're seeing a huge increase in the number of cyber attacks in the maritime sector, and it is growing significantly. If we look back historically, there have been a few incidents that actually had negative effects. Port of Barcelona was targeted 5 years ago. The Maersk attack, which most people are familiar with, was not a sector-specific attack. It was collateral damage coming out of political and military activity in another part of the world, but it had significant economic effect on the company involved and actually did result in a, if you excuse the pun, a sea change in the way the industry was looking at cyber. Moving forward to where we are now, in relatively recent history, certainly within the last year or so, all of the big four shipping lines have been attacked in some way in the cyberspace. Most commonly these days, ransomware targeted things on board the vessel to make basically a profitable industry out of holding the shipping industry to ransom. There is a lot of money within this sector. So being able to target in a way that you make money out of it is actually very profitable. So ransomware for the sector is now becoming quite common. We also know that for other reasons, not just economic reasons, there are bad actors who'd be very interested in targeting the shipping sector. A very large percentage of goods throughout the world, and certainly within the UK, a huge percentage of goods are moved by ship. If that supply line is disrupted, we can see that it's not very long before there's significant national impact. We recently saw an event where a ship blocked the Suez Canal. In 3 days, there were on the order of tens of billions of dollars loss in productivity and economic damage. And that was accidental. As the sector develops, there'll become more and more deliberate attacks. Why do I say that? Well, if you look at the maritime infrastructure, it's pretty complicated. You have ships, you have ports, you have manifest systems, you have cargo handlers, you have people. It's a very large system of systems. And any system that complicated has a very significant attack surface the malicious actors can take advantage of. And we're now seeing that they will. And it's going to get worse. I mentioned part of the issue was that we have all of these different parts of the sector. Each of them are getting more complicated. On board vessels, there are more and more electronic channels used for everything from communication, sensors, controls. As individuals interacting with the sector, whether that's as crew or as passengers, we are carrying more devices and they all interact. And the Internet of Things, being everything connected to everything else, just basically ups the number of possibilities for harm from our point of view. Okay, so that's kind of, oh dear, isn't the world terrible? Shouldn't somebody somewhere do something about it? So we're actually some of the people who are being those someones and trying to do something about it. One of the things I do at the university is lead the Maritime Cyber Threats Research Group. Not surprisingly, I claim this is an interesting group. I think there's evidence to back it up. As far as I'm aware, it is probably the largest group of its kind that you'll find anywhere. In particular, the diversity of backgrounds that we have within the group, ranging from genuine cyber geeks right through to people interested in AI and application of AI, out to business logistics, psychology, policy, and even history. All of those things come together within the group to give many different perspectives on what really is a global and genuinely multidisciplinary problem. There are many things in the world these days that are very hard to solve with just a single point of view. And even transdisciplinarity, where you transcend the pieces into a greater whole, is definitely necessary to look at some of these things. And we think that cyber in the maritime space is very much one of those because of the reach that it has and the impact that it has across so many other sectors. So we think that we're actually in a unique position to look at both problems and solutions to vessels, ports, operators, and all of the security and economic implications of that. A couple of things that we bring to the picture that are now reasonably well developed are different ways of looking at risk within the sector, trying to make it both accurate, quantified, but also understandable and meaningful to the end users. Sometimes when people working in this space, they communicate very well with the aforementioned cyber geeks, but do a pretty poor job of explaining to people why it is a relevant problem and what an appropriate solution is. Part of the way we're looking to contribute to the solutions are very much the cyber ship lab that we're talking about today, where we are looking at presenting real world issues and building real world solutions to those issues. So usually about this point, somebody says, well, isn't cyber kind of a done deal? Haven't we been doing it forever and don't we know all the solutions? I'm prepared to categorically say no. IT and cyber, very well studied, very well developed solutions in a lot of the space. Even production systems, things like SCADA systems, have had a fair amount of attention. And a lot of people have said, well, you know, aren't ships just another instance of a SCADA system, just like a factory or something else? My answer to that is definitely no. There are very few factories that move from one country to another, change radically the people and behaviors working with them, and actually have to move through some of the most dangerous parts of the world to get to where they're going. So there are a large range of vessels within the fleet, ranging from very low people involved, bulk carriers and so on, right through to large cruise liners, which have thousands of people on board. The systems supporting those ships are very different. The locations that they go through to get to where they're going are very different. That means the people interested in doing bad things are very different. They also have different levels of resources. So, you know, like it or not, if Russia or China decide that they really, really, really need to compromise the system, they probably will. But the average ferry running between the UK and France is unlikely to attract that level of attention. and therefore probably don't need to spend the enormous budget to militarily harden their systems. So it's getting that risk profile right and getting it right in a dynamic way, because the circumstances of operation, the cargo, the crew, the route, all make a big difference. And a lot of this will also be enhanced as people get more and more interested in developing ship technology for efficiency, better routing, better use of energy on board, more technology. From our point of view, more vulnerabilities. So how do we kind of solve this problem? Well, as I hinted at, we want to look at the real problem and try and come up with real solutions. And that's what the Cyber Ship Lab is all about. The lab is deliberately not a software and simulation environment. Yes, we do look at software and we're interested in vulnerabilities of software, but also beyond that, real physical hardware has different properties to any simulation, and that's what we look at. The software and hardware also carry information that is useful in different ways. So our aim is to try and come up with protections for the sector across this complete spectrum of devices and programs of interest. We can configure the lab in a variety of ways, ranging from beyond state of the art, working with manufacturers to look in next generation technology, right through to the oldest piece of kit that might be the biggest vulnerability in any system if it's still there. And we want to be able to configure that according to profile and in a very easy manner, so it's easy to compare old with new, changing one device with another. We're interested in both fundamental research. We are an academic institution. We want to produce really good papers, but also being practically useful, working with partners to solve the problems they're actually looking at. So what will come out of that? Certainly increased knowledge, but also tools that can realistically be used to help protect the sector. Lab's made up of two pieces. There's front of house, the console, where we have the tools and the screens, the visualization software, the attacking and pen testing software that allows us to do what we do in a lab. Now notice this doesn't look like a ship. It's not supposed to. This is an environment for experimentation. It's a laboratory. It's where we look at things and poke at things. We do have a ship simulator around the corner, and we'll talk about that in a minute. The other side of the wall, we have kit. The more kit we have, the better we can configure a system to be exactly what it is we want to test for the people we're working with. So quick hint, if anybody on the call has equipment that they'd like us to look at, we're more than happy to do that. And again, despite being a test environment and using simulation for some aspects of things like routing and inputs, this is real hardware, ideally as close as possible to the way it's connected and deployed on a real bridge. We've got some other projects going on within the group that I'll just quickly pass through. The first one, MACRA, Horizon 2020 sponsored project called CyberMA, is interested in risk assessment. We have developed a unique approach to risk assessment, which when I'm wearing my academic hat, I call a dynamic, multidimensional, highly parametric risk assessment model. But when I'm talking to people in the maritime sector, I show them nice little graphs like on the right-hand side of the screen, which makes it clear what they should be worried about in their circumstance at this point in time. MACRA has been quite successful within the industry at the moment, and I can genuinely say award-winning, since the paper on which this is based won the Lloyd Science of Risk Prize this year. So we're definitely in the right direction for both scientific work and making it useful to people. I mentioned CyberMA earlier. This is a project that Plymouth is a UK partner in. It's a large European project with 13 partners across Europe, both academic and industrial. The aim is to try and increase awareness within the sector and the supply chain about cyber risk, using simulation, using appropriate risk models, appropriate analysis to genuinely understand what the sector needs to be concerned with. And we're a key partner in that. Plymouth's in a unique place in this sector. The Plymouth ecosystem has a number of pieces that you just won't find anywhere else. For all of our interested partners, we can provide The Cyber Ship Lab is somewhere to basically do a threat exploration of the systems they're concerned with. Given that understanding, we can produce a meaningful and comprehensive risk report out of the macro system. Building on that, we can go across to a cyber range and craft malware that can deliberately expose a particular scenario that we're now concerned with. We can take it back to the ship lab, prove that it actually works on real hardware. And then we can take that scenario, get a real crew out of one of our partners, put them in a full bridge simulator, and show them how this would play out in reality. There is nothing like watching people change from, yeah, but could that really happen, to, oh dear, that did just happen to us and it was our crew. We can also take it out to the real world with autonomous drones and with the capability within Plymouth as a smart sound to operate with a highly instrumented part of the ocean where autonomy and remote control is very possible. And again, the bottom of this diagram is our partners. These are people we want to provide solutions to. And that's kind of what we're interested in doing. Quick run through the things we're interested in. Cyber attacks are happening, they're not being noticed. We want to both protect systems and collect data to make it more clear what is going on. We're looking at how can we investigate attacks and how can we use advanced technology, including AI-based technology, to develop better tools for both intrusion in attack sense and intrusion in detection sense. And then ultimately, we want this to feed into regulatory and insurance agencies, which will change normal standards of operation within the sector. It's going to get worse. There's no doubt about that. We're just seeing more and more technology coming into the sector. And when we move beyond ships into smart ports, even smart cities, the Internet of Things, autonomy, this is going to be a very interesting sector for a number of years to come. And we're very happy to be on the leading edge of that and intend to continue to develop those capabilities. Having set that scene, let me now pass over to Dr. Kimberley Tam, who'll give a quick run through some of the actual scenarios we're playing out to give you a flavor of what it is we do. So Kimberley, over to you.
Thanks, Kevin. Share my screen now. Hopefully that's good. So as mentioned, I'll walk through a couple of scenarios. Sorry, I'm gonna just, oh, okay. We'll probably have time for one or two. We have about 5 available, but we'll just kind of run through a couple. So the first one that we wanted to show was a man-in-the-middle attack. So this is a fairly standard type of attack on systems where if you have two and they talk to each other, an adversary basically just jumps into the middle and is either listening in onto packets, so kind of just listening in, seeing what's happened, or even manipulating these messages. And that can have some more serious consequences. So we wanted to look at that in more detail. One of the interesting things we get to do with this lab is because we have a number of systems set up with a lot of different connections, we get to kind of pick and choose at which points we want to try and launch a man-in-the-middle attack and see if it can be done, and if it can be achieved, what can we actually do with this access. So especially things like data poisoning to change how certain systems work or the data being displayed to people. Those are all things we can do with a man-in-the-middle attack. So in this first demo, we have a couple of components involved. So we have some off-the-shelf serial to IP converters. Since there is a number of systems that talk in serial data or Ethernet, and we need to kind of bridge that gap on a ship. We use a lot of GPS data. Navigation systems are a kind of a key system that people have a lot of concern about, so we definitely look at that. In this case, we look at NMEA 0183. Not to get too much into detail, but there are several different protocols that these systems can talk to, And as we are working with real systems, we can be accurate down to the wire and to the packets going across it. So in this particular case, because of the systems we have and because of the ship that these systems are being configured to look like, we're doing the older version of the NMEA protocol. So here we can start to modify messages and send false packets, and this leads to misinformation on another navigation system called an HackTheSea, which changes how the kind of screen looks like. So here's a quick example of what an NMEA message looks like for this version. And some of the things you're interested in are these. So these are just kind of the packets you would see on the wire. Particularly going, let me pull up a pen. Here where we're doing our man-in-the-middle attack. So there's a couple of components involved, which is interesting from the security point of view, because it's not just, again, two systems and one attacker. But we can have accurate messages coming from the GPS receiver and having an accurate serial converter and routers and accurate wiring. The only issue is, since this lab is sitting in one location and ships move, we do need to add a little bit of simulation to be able to just essentially drive the systems. But most of it is real hardware. Some of these have slid over a bit, so apologies for that, but in order to decode the messages, there's certain formats that are defined by NMEA. And when we know that format, we can then start to alter things. So if you're a man in the middle, you can start playing with timestamps, in this case, latitude and longitude, which can cause some havoc if done in the right way. In this demo, one of the things we first tried to modify was something called speed over ground. And one of the fun things with that is it will, one second. Is it playing? Yeah, okay. So here we have Linux, which is our pen testing station, and it is watching the packets as the man in the middle, so watching the packets in transit. This data then gets sent to the bridge, and this is what the crew on the bridge would see. And we have the attacker watching the stream, and when it finds a speed over ground value of 4, it replaces it with 50. So that is the origin of the data, and where it ends up is different because of the man-in-the-middle attack. So this is actually relatively basic, since we are statically looking for one value and replacing it with another. Now that we know that it's possible, we can start looking at more delicate and interesting live versions. And in addition to that, we're also very interested in how do we visualize this in a way that people can understand what's going on. So in addition to the pen testing tests we have, we're also working on ways to better visualize this. So instead of the bridge view, which would make sense to crew but not to others, we are developing visualization software. So in this case, you can easily see the data going from the GNSS to the HackTheSea, which is the display we saw earlier. And here we have where we can drop a man-in-the-middle attack. So in a moment that will go red when the attack gets started. And then, oh, there it is. So the man in the middle has been initialized. And you can see in this case, instead of affecting the speed over ground, we are affecting the rudder. And you can see the white ship is the intended route, so what it was supposed to be without an attack. And at the point of the attack, you can see the red ship, which is where it is after the rudder angle has been changed. So as with everything, the hardware is being developed, the pen testing is being developed, but also these visual aids are being developed. And some of the things that is currently being implemented is having 3D views of the ships, better network diagrams. So this is fairly basic, but we're hoping to be able to drag over, click, and control how these networks are set up. And also, as we have more configurations available, how to enable and disable different boxes in this wider network view. In addition, better network packet analysis and visualization for people interested in networking. So as I mentioned, in the future, we have a couple of things we're interested in doing with this particular demo, especially kind of editing contents on the fly, so real-time changes and more fine-grained changes, so not just a static, if you see a 4, change it to 50, and putting kind of more logic into the attack. As I mentioned, this is in one point of the network, so we did it between, think of the HackTheSea and the serial converter. But as you saw, the whole ship has many nodes and connections, so looking for other places to launch a man-in-the-middle attack is of interest. And of course, we've only seen the change in speed over ground and a change in rudder, but there are a lot of other things in NMEA messages that can be manipulated, and we're interested in seeing how that could affect human-in-the-loop decisions. So if the change data is going to the bridge, how can that affect people? But also see how manipulated it can affect machine-based decisions. So as we go into more autonomy, would autonomous AI be smart enough to detect malicious information? And what would it do with it? Would it ignore it? Would it try and fix it? What would it do? A couple of, one theme that you may see a couple of times in our demos, as we develop more attacks, we're starting to see that, the alarm systems in a ship are very good for things like fire, collision, and things like that. But there's not a lot of alarms or ways to notify people of a cyber attack. So one of the things we're looking at as we do more of this pen testing and things is how do we communicate this again to the people. And lastly, I just wanted to mention, we saw the effect of changing a rudder angle or changing the speed over ground. Can we achieve the same effect, but looking at different systems? So exploring the interconnectivity between all these systems, which is something that I believe is fairly unique to our lab setup, because we really are looking at that big systems picture. So I have a couple more minutes, so let's do the second demo. So in a similar way to the man-in-the-middle attack, being able to attack the rudder, we tried to find a place where we can, again, same outcome, but different point of attack. So in this demo, we tried to go a lot closer to the mechanisms, so down at the rudder level, and less at the bridge level. So it's an interesting way of trying to see if we could do a same attack, but closer to the physical mechanisms. So you guys actually saw a quick view of the, oops, rudder. Hopefully that's not too loud. I don't know if you can hear that. I can't seem to mute it right now. That's okay. So we've figured out, or we've looked into the configuration from bridge to the steering gear and been able to find all the pieces. No video. Good. Okay. It's not it's not the most pleasant of sounds, so that's good. So we have all these several components from the bridge to the steering gear room, and we can accommodate for different NMEA formats, and also it will adjust to the size of the ship that we tell it is, because that changes the rate of change for the angle. This is the rudder. You can also see a peek at the thruster below it. We're actually probably going to add 2 more thrusters so we can have 1 in the front, 2 in the back. So that will probably be adjusted as well. Plenty of things like angle sensors, and again, several modes of communication, not just NMEA 0183, which we talked about earlier. We're going to be connecting it to the ship simulators, which should be pretty interesting, because then we can see what it would look like in the port or in the middle of the sea, and then see the physical rudder actions that would be a part of that. Not only that, as soon as we implement the attack, you can see on the screen the ship start to drift, or what they think they should be seeing versus what is actually happening, and to help visualize and demonstrate that attack being useful. So unlike the previous example, this one alters the physical movement, so there's less bridge visuals in the digital sense. And we are crossing this over with the EU project mentioned earlier a little bit. In that project, we are working with the Port of Valencia. So we are combining the physical rudder, the cyber attacks, but also our ship simulators to kind of understand if we could impact the rudder in a certain route, how would that affect the port? So could we block ships going in? What would be the effect of that? Because we can talk to the port directly about throughputs and repair times. So trying to get that larger picture on what these attacks could actually result in, and how they could affect the supply chain. All right. Thank you very much, everyone, for your attention today. And that concludes our presentation. Our contact details should be on the thank you slide. So if you're ever interested in getting in contact, please do. Thank you again, and enjoy the rest of your day at DEF CON.